Welcome, everyone, to today's Explainer. We're diving right into a global giant. I mean, you literally use it every single day. You wear it in your favorite t-shirt, you spend it as a paper banknote, and you even use it to heal as a medical bandage. We are, of course, talking about cotton. People often call it white gold. It's actually the world's largest non-food crop, and trust me, its story is absolutely miraculous. Okay, let's dive into this. Here's our roadmap for the explainer. First, we'll trace a 7,000-year thread. Then, we'll look at the anatomy of white gold. Third, we'll explore the single-cell miracle. Fourth, we'll go from the field to the gin. And finally, we'll look at the final fabric. All right, Chapter 1, a 7,000-year thread. Let's look at the history of cotton. So humans have actually relied on cotton for over 7,000 years. To put that in perspective, historians found early cotton fabrics dating way back to 6,000 BCE in Peru and 5,000 BCE in India. From there, the idea spread like wildfire. Moorish traders brought the crop to Europe around 800 CE. But, the absolute biggest shift happened much later, in 1793. An inventor named Eli Whitney patented the cotton gin. And wow, this machine literally changed the global economy forever. But actually, before we get into the science of it all, let's look at the language. It's super interesting. The modern English word cotton actually comes directly from the Arabic word kudn. It really highlights those ancient Middle Eastern trade routes that first carried this incredibly valuable material all over the world. Moving right along to Chapter 2, Anatomy of White Gold. We're zooming in on the cotton plant itself. Now, let's lay down some basic vocabulary so we're all on the exact same page. Biologically, cotton belongs to the Malvaceae family. That means it's basically a cousin to okra and the beautiful hibiscus flower. Okay, so 3 key terms for you. First, lint. That's the word we use for the raw, fluffy fiber itself. Second is the boll, which is the hard, protective pod that holds all that fiber. And finally, ginning. This is the mechanical process of actually separating that lint from the seeds. Now here is a totally surprising fact for you. 9. Yep, 9. That is the number of feet a single cottonseed's taproot can dive down into the soil. It's wild. Within just 3 days of getting a bit of moisture, the seed sprouts a root that just pushes massively deep into the earth to find water and survive. Meanwhile, up above ground, the plant goes through some very specific growth stages. First up, it pushes out cotyledons. Those are the seed leaves, just to get some early energy. Next comes a stage called squaring, which is basically the formation of these tiny triangular flower buds. And then comes the flowering stage. And you know what? This part is incredibly brief. The flower opens up creamy white on the very first day, changes to bright pink by the second day, and turns dark red by the third. Then it just falls completely off, leaving only the green boll behind. So you might be wondering, how do farmers actually know when all of this is going to happen? Well, they don't rely on unpredictable calendar days. Instead, they use something called heat units, specifically a simple math formula known as DD60s. It acts like a physiological clock, tracking growth based entirely on daily temperatures. Basically, if the temperature drops below 60 degrees Fahrenheit, the plant just pauses. It takes a break. It only grows when it's nice and warm. Okay, let's zoom in even closer. Chapter 3, the single-cell miracle. It's time for some microscopic biology. I want you to think about this for a second. When you hold a soft, fluffy, white cotton ball, what exactly are you holding? Well, the scientific reality here is absolutely amazing. Every single tiny fiber in that cotton ball is just one individual biological cell. No way, right? But it's true. It's an epidermal cell, basically an extension of the seed's skin, that has just stretched itself way, way out. And inside that protective boll we talked about earlier, it gets incredibly crowded. As the boll matures and finally bursts open, it can contain up to 500,000 of these single-cell fibers packed inside. 500,000 individual cells in just one single boll, all reaching out for the sun. So how does a single cell get so long? First, the cell creates a super flexible primary wall. This lets it elongate incredibly fast, up to 2 inches in a single day in the right environment. But once it reaches its full length, it completely stops growing longer. Instead, it starts building a really thick secondary wall on the inside, made almost entirely of pure cellulose. That tough inner wall is the absolute key. It's what allows the dried fiber to eventually be twisted and spun into really strong yarn. Let's zoom back out now. Chapter 4, From Field to Gin. Time to look at harvest and processing. Right, so when the crop is finally mature, it gets chemically defoliated. If you aren't familiar with that term, it just means all the green leaves are carefully removed, leaving only the white bolls behind on the stem. This is super important because it allows these massive, highly automated machines to drive right through the fields and pick the cotton without getting all tangled up in the leaves. Now, those huge machines are harvesting what we call seed cotton. This is a really crucial term for us today. It basically means the white fiber is still firmly attached to those hard little seeds. When all of this arrives at the ginning facility, these incredibly powerful vacuum pipes just suck the raw harvest inside to begin that all-important separation process. Once inside the gin, the machines have a tough job. They need to remove all the trash, the leftover sticks, hulls, and leaves. Modern circular saw gins have to balance this perfectly. They need to aggressively pull out the debris, but they also have to be gentle enough not to break those delicate single-cell fibers we just learned about. It's a real balancing act. And to pull it off successfully, the moisture of the cotton has to be kept right around 5%. And that brings us to our final stage. Chapter 5, the final fabric. Let's look at the global market. So, the crucial point is this. Once the lint is perfectly clean, it gets pressed under immense pressure into these highly dense blocks. We're talking wrapped bales that weigh a massive 227 kilograms each. They are literally so heavy they have to be moved around by forklifts. From there, they're ready to be safely loaded onto ships and sent off to textile mills all around the globe. But here's something really cool about the cotton industry. Absolutely nothing goes to waste. Remember those seeds we separated out? Well, they actually make up 53% of the total harvested weight, and they get transformed into all sorts of things. Protein-rich feed for dairy cattle, pressed cottonseed oil for everyday cooking, and they're even processed into plastics and cosmetics. It's the whole shebang. Now, because raw seed cotton is super bulky, efficiency is literally everything. For example, in major growing regions like Australia, these massive cotton gins are strategically placed right next to the farming regions. It makes perfect sense, right? It minimizes transportation costs and ensures the whole process stays profitable long before the clean bales ever hit the ocean ports. So we've gone on quite the journey today. We've zoomed all the way from ancient civilizations down to a single microscopic cell and right back out to a massive global supply chain. So I want to leave you with this final provocative thought. How will you look at the cotton clothing you wear, the money you spend, and the bandages you use to heal now that you actually know the 7,000-year single-cell journey of white gold? Thank you so much for joining me on this explainer, and keep exploring.